Okay, now we continue with the E1 frame. But before we start with E1 frame, we need to understand about E1. What is E1? E1 is a standard for transmitting the digital signal over telecommunication network. It is a part of PDH and it is widely used in Europe and the other part of the world. So now we learn the key characteristic of E1. So we can divide it to 4 points. One is data rate. An E1 line transmit data at rate 2.048 Mbps, or we can call 2 megabit. Channel 2, a channel. E1 is divided into 32 channels, each with a data rate 64 kbps. Of this, 30 channels are used for voice or data transmission, while 2 channels are reserved for signaling and synchronization. So 1E1, it has 32 time slot, or we can call 32 channel, or one time slot is 64 kbps, and time slot 0 is for synchronization, and time slot 16 is for signaling. Okay, third is frame structure. E1 use a frame structure to organize data. Each frame consists of 32 time slots, each 8 bit in length, result in a frame size of 256 bit. Frames are transmitted every 120 microseconds, corresponding to an 8 kilohertz frame rate. Okay, point number 4, frame and synchronization. E1 frame includes synchronization bits that have maintenance alignment between the transmitting and receiving end of the communication link. Now we come back with the E1 frame. Okay, the PCM involving sampling, quantizing, and encoding. As a standard voice telephone signal has bandwidth of 4 kHz, it is a sample at twice the 4 kHz frequency. That is, at 8 kHz, this is called Nigis rate. Each sample is converted to 8-bit binary number. So E1, we have a sampling rate of each channel is 8,000 samples per second, and frame duration is 125 microseconds. So the total E1 frame equal to 32 time slot multiplied by 8 bit, so it equal to 256 bit frame. So the basic speed of each channel is 8,000 multiplied by 8 bit equal to 64 kbps. Standard bit rate, or we can say it is a standard bit rate for the single voice. The European recommend system define that the time slot 0 of each frame is used for synchronization, also known as frame alignment. They ensure that the time slot in each frame are aligned between transmitting station and receiving station. The frame alignment word is carried in data bit 2 to 8 of each even frame, while the odd frame carry not frame alignment word in data bit 2. An error check is also available in time slot 0. Using a cyclic redundancy check, or we can call COC, to verify the frame alignment, which is carried in data bit 1 of all frames. There is also a facility report fire an alarm, which is indicated by a binary 1 being inserted into data bit 3 of all out frame. The remaining data bit 4 to 8 of out frame can be utilized for the national alarm and network management. Time slot 16 has 8 data bit available, and by using a variable code of 8 data bit, signaling can be performed for 2 voice channels in each frame. Therefore, it can be seen that 15 frames are required to complete signaling for all voice channels. As there are now multiple frames being carried in the logical order, there has to be a device for aligning this. This is achieved by using the frame prior to the frame contain signal information known as frame 0. Time slot 16 is in frame 0 contain a multi-frame alignment word using data bit 1 to 4 and using indicate the start of multi-frame each, which are checked at the receiving station.